Hello everyone, thank you for watching this video. This video is brought to you by Pragyan Technologies. We are a training institute based out of Bangalore in India. We specialize in networking and network security training with emphasis on details of the fundamentals. So now let me get into the topic. So before I get to VLAN, what is LAN? So LAN is actually a layer 2 segment, layer 2 networking segment, and typically the LAN segment is limited to one office, and the devices in the same LAN can communicate to each other directly. Now the LANs, the Ethernets, typically Ethernet is one of the most popular protocol that you are going to use on a LAN. So now LAN, so what that means that if you have a LAN like this, let me show a topology. Suppose you have a set of machines and they are all connected to a switch, and if you have a LAN like this, then any machine in a LAN can communicate with other machine directly without intervention of a router. So that sounds good. It's simple and it's easy to use. But what is the problem with the LAN? The problem with the LAN is the IP networks uses a lot of broadcast. So every time a machine does not know where to send a packet, there is a possibility that it will use broadcast to identify where to send. For an example, the protocols like ARP, which are fundamentals to IP, uses broadcast very extensively. So that means broadcasts are genuine traffic that IP networks will be using all the time. So now what do you do now? What is the problem with broadcast? The problem with broadcast is if you have 1,000 machines in a network, and let's assume that every machine is generating one broadcast in a second, that's about 1,000 broadcast messages in a second, and these 1,000 broadcast messages are going to each of those 1,000 machines. That means every machine will have to look at 1,000 packets every second and check whether it should be doing anything about it. So that's a huge overhead. It can cause it can take a lot of CPU on each host in the network, and it also actually consumes the bandwidth on each of the link that goes to those PCs. So the bigger the network, the larger the overhead, and higher the performance penalty. So what do you do? So one of the design target, whereas you can't eliminate the broadcast from the network because broadcasts are essential in IP networks for communications to happen. One of the design objective is going to be to reduce the broadcast. So how do you do that? The way you do that is you segment this large LAN into smaller LANs, and this you can do that in multiple ways. You can physically isolate the LANs and then connect them using routers. For example, if I go back to the diagram that I have shown earlier, right, let me go back to this. If I use this topology, if I don't connect these two switches and the machine is connected to one switch, and I make them as a one segment, and the machine connect to other switch in a different segment, and these two switches are not connected directly but there is a router in between, then essentially I have divided this large LAN into two different LANs and they are interconnected using a router. So now what will happen? The broadcast that goes from PC 0, they will only reach PC 1 and PC 4. They are not going to reach 3, 5 and 6. Essentially we have limited the amount of broadcast in each of those segments. So that's a great idea. So you can divide your large LANs into smaller LANs. But what is the problem with that? Problem with that is now your logical topology is bound to your physical topology. That means your physical interconnections needs to be planned very carefully. Right, so if you want a PC 0 to communicate to PC 1 directly, they need to be in the same LAN segment. You need to connect them with a specific switch. You can't connect to some other switch. Now if the user from PC 0 by chance changes his seat and goes to a different location, and the cable from that location goes to the second switch, now your communication will be broken. So now how do you solve this problem? The VLAN solve this problem. So VLAN brings in those flexibility and creates those divisions. So what happens with the VLANs, right? With the VLANs, what you do is you have this large physical LAN. Every device is connected via the switch, and then you divide them logically into small segments, and the two devices in the same segment can communicate to each other. For example, now here I have PC3 and PC5. If I connect these two to the switch ports which are connected to VLAN 10, so VLANs are identified typically by some numbers. So if in the switch I create two VLANs, one is VLAN 10 and VLAN 20, and if I put two PCs in VLAN 10 and other PC in VLAN 20, the two PC3 and 5 will be able to communicate to each other directly, whether PC5 or PC3 will not be able to communicate to PC6 directly unless it goes via a router. So what I have done essentially, I have taken a network segment, a large network segment, and the machines that are connected to a switch, and I've divided it into two different segments. Now how do you do that? The way you do that is you configure the switches. You go to the switch configuration. For example, in this case, let me show you how to do that, right? In this case, what I have done, right now the switches are configured with their default configuration, that is all switches are in the same VLAN at this time. All switch ports are in the same VLAN at this time. So, and all these PCs are configured with an IP address 192.168.10 dot something. Typically the PC3 will be 10.13, PC5 will be 10.15, and PC6 is 10.16. Excuse me. So now you'll see that I should be able to log into PC3 and then should be able to ping from here to all other PCs. So I should be able to ping 192.168.10.15, and I can ping that, and 10.16 I can sorry, that's the typo. So 10.16 I can ping that as well. Now let me go back and log into the switch and isolate this port. So I'm in the switch now, and you must be already familiar with Cisco CLI. So I'm in the configuration mode. Now here I'll put the first two ports into the VLAN 10, and then third port FS0/3 in VLAN 20. So what I'm going to do is interface FS0/1, and let me say switch port mode access VLAN 10. Access VLAN 10. And then what do you see? The moment I say that this port will be in VLAN 10, what switch did is it has created a VLAN with VLAN ID 10. I'll do the same thing for FS0/2 as well, and I'll say switch port access VLAN 10. Now interface FS0/2 0/3. I'm going to put this to VLAN into VLAN 20. My bad, let me put that in VLAN 20. Okay, so now I've configured my VLANs, and you'll see that my port number 1 and 2 are in VLAN 10, and port number 3 is in VLAN 20. Now what is the outcome of this? The outcome of this is going to be that now if I go to my PC3 once again and try to ping PC5, I'm able to ping. Why? Because both of them are in the same VLAN. If you look at here, both of them are in VLAN 10. Now if I try to ping PC6, I can't ping anymore because that's in a different VLAN. So what switch is doing is any packet that comes on a port, in this case it comes on this port and it checks which VLAN this port is part of. If the port is part of VLAN 10, it will send that packet only to the VLAN and other ports in the VLAN 10 only. Of course, the regular switching process applies. It's going to look at the CAM table or MAC address table and it will decide what port to send. But even then, it will also limit, even if it's a typically for a broadcast packet, it's going to send to every port. But it will limit those broadcasts to only those specific ports. So I hope the basic concept of VLAN is clear. So what can we do using VLAN? Using VLAN, we can segregate the network. We can segment the network into multiple segments. And the devices which are connected to one VLAN, they can communicate to each other directly on a layer 2 segment. If you have to communicate from one device on one VLAN to another device on other VLAN, you can't do that directly without going via a router. That's really essentially what VLAN does. Now, let us look at what is VLAN trunking and why do you need that. Now, I'll go back to this diagram again. So as long as all ports are connected in the same, all devices are connected on the same switch itself you configure the switch saying that, well, first 2 ports are in VLAN 10, the rest of the ports are in VLAN 20. As the packet comes in, switch will look at, well, which port the packet came in and which ports I'm allowed to forward it through. That works great. But what happens when you have some VLANs connected to one switch and other VLANs connected to another switch? Right? For example, in this case, VLAN 10, some devices of VLAN 10 connect to the switch 2 and some 1 is also connected in VLAN 1. Now what happens? So that means that the interconnecting port, in this case FA0/4, should be part of VLAN 10. Otherwise, PC0, which is part of VLAN 10, will not be able to communicate to PC3, which is also part of VLAN 10. So that means FA0/4 in switch 1 should be part of VLAN 10 and FA0/4 in switch 2 should also be part of VLAN 10. Right? Similarly, because we have PC4 which is part of VLAN 20 in switch 1 and also PC6 which is part of VLAN 20 is in switch 2, they need to communicate to each other. So you need FA0/4 to be part of VLAN 20 as well. Then how do you do that? So and also, you know, the VLAN configuration is a device specific. Now if a packet goes out through this port, right, let's assume that I made this part of VLAN 10 as well as 20, right? But when the PC0 sends a packet, that means the switch 1 is going to forward that packet in VLAN 20 because the FA0/4 is part of the VLAN 10 and PC0 is also part of VLAN 10. However, once it reaches the other switch, how does that switch knows that actually this frame should be part of VLAN 10 or VLAN 20? So that means you need to have some additional information added to that frame so that the receiving switch can understand which VLAN I'm going to forward it to. Right? So that's why you need the protocols like VLAN trunking protocol. So what VLAN trunking protocol like 822.1x is going to do, 822.1q is going to do is when a switch is forwarding a packet to a trunk port, is going to add additional information into the frame. Right? So it's going to add what is called VLAN tag information. VLAN tag information is going to carry the VLAN number this frame is part of. So now in this case, if switch 1 receives a packet from PC0 and it needs to go to PC6, when this frame is exiting via FA0/4, the switch 1 is going to add the VLAN tag information into the frame. And the tag information is going to say that this frame is for VLAN 10. So when the switch 2 receives this frame, switch 2 will ensure that this frame is only forwarded to the ports which are part of VLAN 20, in this case only to PC6. The frame will not be forwarded to rest of the port. Right? So I hope that explains why do you need the VLAN trunking protocols. So typically you will use VLAN trunking protocol on the ports which are carrying multiple VLANs, and which will typically be going to be the switch ports which connects to other switch interconnect ports. Sometimes it can also connect to the servers, but typically that's how it's going to be. Right. So now we'll look at how very quickly how do you actually configure switch ports with trunk port. So in our case, I need to make FS0/4 to be a trunk port. I'm going to do switch port mode. Right. So you'll see that there are multiple options. I have 3 options when I configure a switch port. The first one is access. Access port means that this is a port that's going to connect to end device, and typically this end device does not understand the VLAN tagging. So the moment I make an access port, typically all my ports that connects to my end devices are going to be access port. Now I want this port to carry multiple VLAN information, so this has to be either trunk or I can say dynamic. Right. So trunk means I'm explicitly saying that this port is going to be a trunk. Now the moment I make this as a trunk, I need to make sure that other end of the switch is also a trunk. Right. I think that's going to work fine. But if I don't want to say this explicitly as a trunk, I have an option to mention it as a dynamic. When you do dynamic, what happens is the switches, both the switches will do the dynamic negotiation and decide whether this should be a trunk port or it should be a access port. Right. So in dynamic, you see that there are 2 options. One is desirable and auto. So when you use auto, what's going to happen is switch is going to wait for the other side, the switch on the other side, to initiate the VLAN trunking negotiation. If you use dynamic, then that switch port is going to initiate the VLAN trunking negotiation. So that means for 2 switches to form the trunking, at least one side have to be configured with a dynamic. If both are dynamic desirable, if both are configured to be dynamic auto, they will not form a trunking relationship. So in our case, what I'm going to do is I'm going to configure that as a trunk. Right. So I've configured this as a trunk manually. I need to do the same thing on the other side as well. So let me come to this switch and then say that conft interface FS0/4 switch port mode trunk. Right. So now both of them are trunk. Now both of them will be able to carry all the VLANs. Right. So now you want to restrict the VLAN IDs that port should carry. Then what you can do is you can say switch port mode trunk, and you'll have a allowed VLAN. Right. So you'll have switch port mode trunk, then switch port trunk allowed VLAN. Then you can mention what VLANs do you want to allow. So you can specifically mention, say in our case 10, 20. So that means I'm going to allow 10 and 20 on this port. Now if I look at show VLAN, you'll see that I still have 10 and 20 there in the access port, right? And then my FS0/4 is my trunk port. So my trunking is configured. Now I should be able to, I need to assign this PC0 in VLAN 10 and PC 1 and 4 into VLAN 20, so that the switch 1 is configured properly as well. So what I'll do is, let me come to switch 1 and then switch 1 interface FS0/1 switch port access VLAN 10 and then interface FA0/2 switch port access VLAN 20 and interface FA0/3 switch port access VLAN 20. So with this configuration, now I have assigned FS0/2 and 3 into the VLAN 20 and FS0/1 into VLAN 10. So now what I will be able to do is I should be able to now ping from PC 0 all the way to PC 5 and 6. Now if I say ping 192.168.10.15, I can ping. If I try 10.16, this should not ping, right? However, if I go to PC1, because PC1 and PC6 are in the same VLAN, I should be able to ping from here to PC6. So let's ping to 16 and I can ping it. So that's very briefly what is VLAN is about, right? So you'll see that as I configure the VLANs, and if I look at show MAC address table, you'll see that in the MAC address table it also has the VLAN information now, right? So that's really very briefly what is VLAN, and I hope you found this session useful, and please share your comments and feedbacks, and yeah, we're looking forward to your feedbacks. Thank you. Have a good day.